Hi, welcome back to the channel. I'm Dylan, and today we'll be going through a Maths A-Level Edexcel Paper 1 question. This is a proof question using trigonometry and a knowledge of integration and differentiation. So we'll first begin with part A, where we've given a substitution to show that an integral equals a different integral. To begin this, we will write out the first integral we're given, and we can split it up into different sections where to apply the substitution. To begin, we will be turning the dx into a d theta. The way I like to do this is writing the substitution equation of x equals a sine squared theta. Apologies for my handwriting. Where we can work out d theta by differentiating this to get dx over d theta equals a, and we need to work out what the derivative of sine squared theta is. You can split the sine squared theta into two parts as the following, where we can take the squared out, and it's a bit easier to see that you can do this in two parts. Firstly, we'll do the brackets where we have the squared, so we can get this as 2 sine theta. Now we need to differentiate what's inside the brackets, and we get cos theta. So then our result down here for dx by d theta will be a 2 sine theta cos theta. So we can rewrite this as dx equals 2a sine theta cos theta d theta. There's a lot of terms, but at the end we will be combining them together. Now we can substitute x into the different parts of the equation, but first we need to look at the limits. As seen, we have the limits of a and 0 for a term of when we have dx, but we are now trying to get an integral in terms of d theta, and the way to get those limits is by using the substitution equation again. So if we rearrange the equation to get theta as the thing we're working out to get, we can do the following. We'll move the a first to the other side to get x over a equals sine squared theta. Next, we'll put a square root over this one and remove the square here. So just sine theta equals root x over a. Now we can do arc sine, which is the inverse sine, sometimes written as sine to the minus 1, but this, just to be careful, does not equal 1 over sine of x over a equals theta. Now we can make the substitutions of x equals a and x equals 0 from the integral given to us here. To work out what both of these are, we can draw a sine diagram here, where the limits are 1 and minus 1, and we have pi over 2, pi, 3 pi over 2, and 2 pi. We can draw the sine curve as the following. Now, when we substitute in x equals a into this equation, we get a over a equals 1, and the root 1. So we can look at this diagram here and work out when we have an answer of 1, we can do a dotted line here to 1 and down and find out that theta equals pi over 2. Next, for 0, we can look where it's first 0, and we find it 0 immediately at 0. So theta equals 0. So now we have our limits. We are going to substitute in the equation for x into the rest of the equation. This can be seen as the following. So integral between limits of 0 and pi over 2, x to the half, which can be written as a sine squared theta to the half. Now we have the root of a minus x, which we'll be writing as a minus a sine squared theta. Now we want to replace the dx with the equation we have over here, so we can write 2a sine theta cos theta d theta. Now to simplify this equation, we will do the following. First, we will try and collect like terms, so we will have a to the half sine theta, this is expanding out the brackets here. Next, we will take this and take the a out of the square root, where we can write this as root a times root 1 minus sine squared theta. Now we can write as well 2a sine theta cos theta d theta. Now we'll try to simplify this. So we can see that we have a to the half and a root a, and an a as well. This clearly can be written as a to the squared, as a to the half and a to the square root are the same. Next, we'll move the 2 into the front as well, and we will simplify the sine thetas to be sine squared theta, and the cos theta just to be cos theta, and write a d theta. You might have thought I'd forgotten the 1 minus sine squared theta, but this can be written as the following. 1 minus sine squared theta, if you remember your trig terms, equals cos squared theta. And then square rooting that just gets cos theta, so we can add that back as a squared. Now we might be looking at this and thinking we need to get to the form that's not exactly the same, and a big indication of how to do this is this 2 theta here. If we look at our equation we have at the moment, we have only a theta inside the trigonometric terms, and as well a cos squared theta. The way to simplify this is remembering another trigonometry equation, which is sine 2 theta equals 2 sine theta cos theta. We can simplify this by, or we can change this equation to suit us by just moving this 2 to the other side. So we get sine theta cos theta equals sine 2 theta over 2. Now if we square both sides to get sine squared theta cos squared theta equals sine squared 2 theta over 2, over 4, we can then substitute this back into here. So we can substitute this for this, and we'll write this equation as pi over 2, 0 to a squared sine squared 2 theta over 4 d theta. Now, slightly changing how this equation looks, just moving the a squared to the outside and combining 2 and 4 and also moving to the outside, we will get 1/2 a squared integral from limits pi over 2 to 0 sine squared 2 theta d theta. And this is part A of the question. Next we need to use algebra to show that this integral equals k pi a squared, where k is a constant to be found. So you might be looking at this and a bit confused on how to integrate a sine squared. Well, if you remember another trigonometry equation where sine squared theta equals 1 minus cos 2 theta over 2. And you might be thinking, how can we use that when we only have a theta here and a 2 theta here? Well, if you remember, this equation can just be applied, so we can write sine squared 2 theta as 1 minus cos 4 theta over 2 by just taking this 2 and timesing it by the 2 theta from the equation before. Now substituting this back into the equation, we get 1/2 a squared pi over 2, 0, 1 minus cos 4 theta. I always like to just split up the fraction into 2 parts as it makes the integration a lot easier. So we can now integrate this, as I'm sure you know how to integrate cos. This gets 1/2 a squared. So to first, integrating a half, as there's no theta in the half term, we can write this as 1/2 theta. Next, the cos theta will integrate into a sine theta, and we'll take this constant times by the theta and put 1 over 4 to the edge. So this goes out to minus 1/4 sine 4 theta over 2. And then we have to remember our limits of pi over 2 and 0. We now need to apply these limits to this formula, so we can rewrite this as 1/2 a squared brackets 1/2 pi over 2 minus 1/8 sine 4 pi times pi over 2 is 2 pi, and then we have to apply the 0 terms, so 1/2 times 0 will just be 0, but I'll write this out for completeness, and a sine with a 0 inside will also just be 0. Next, we can just work out the rest of this equation. So we get 1/2 a squared, where 1/2 times pi over 2 is pi over 4, and then sine to 2 pi, if you remember our graph from up here, is equal to 0. So this can be just minus 0, minus 0. So we only have the pi over 4, and we work out that it is 1/8 pi a squared. Now we compare this to our question to begin with, and we get that k equals 1/8. Thank you for watching. I hope this has helped, and I wish you the best of your studies.